Okay, so who am I? My name is Etienne Caron. I hail from the just as wonderfully warm country of Canada, Montreal. So it was nice. I stepped off the plane. I was like, oh, this is just like home. I quite like Minnesota and Minneapolis. So today we're going to be talking about, I'm going to be presenting a simple MVI architecture pattern for Android. I see Lloyd here, so we have trouble recording. We're just going to start. Yeah. All right, cool. So, a little bit about myself and about why MVI is an interesting pattern to learn. So, learning programming in general, right? It's often compared to gaining a superpower. I keep hearing this lately. It's kind of an interesting metaphor. For me, my first job in 1997, coding websites in Unix C, VI, Unix command line, superpower number one. Like, that's what got me started. I still use this weekly, I would say. And then I discovered PHP in 1999. I think it was version 3 back then. Oh, no more hand parsing HTML templates. That was superpower number 2. Right up until I discovered Serious Java in 2001. And PHP was kryptonite all along. Sorry for PHP developers. It's a little burn. I love you guys. 2009, 2011, for me, mobile development on Android and iOS, I discovered that. That was literally like the best superpower ever. So mobile, right? A lot of fun. Fast forward a few years, and I think my new superpower in my career is going to be reactive functional programming. I think it's the coolest superpower so far. It's really a lot of superpowers in one. You get immutability and unidirectional data flow. So that's Colossus right there, right? You're invulnerable against rogue mutations. That's pretty epic. Functional programming, pure logic, things can't go wrong. It turbocharges your code reuse as well. Functional programming is really good for that. You get little functions that you write, and you can reuse them everywhere. I don't think I was really reusing code when I was writing imperative, object-oriented code. And when I really discovered how much code reuse functional brought to the table, I was really jazzed. Then RxJava, which allows for safe parallelization of work. You can be everywhere at once, right? These superpowers all sound pretty awesome, but if you're not careful, they can really screw you up. The complexity and learning curve of RxJava, as well with the new language, Kotlin in this case, you sort of have to be careful what you're doing, and you have to have a solid approach. So I lied. It's not that simple. But the thing with RxJava and Kotlin is it will simplify your life if you use them with the MVI pattern. And the way it simplifies your life is really by not allowing you to forget about anything that you would typically just shove in the back of your mind. Stuff like asynchronous processing, you have to handle it. You have to know which thread this background job is going to run. Canceling in-flight requests, we often don't even think about that, right? We launch a web query, and then the screen rotates, and all havoc happens, right? Handling server error states, like what happens when the network's not there, you lose packets, like all that stuff, we typically don't think about it, and it results in instability in the app and crashes. So using the MVI approach with Rx and Kotlin, you're not allowed to step away from any of these problems, which actually is why it's a bit complicated. But in a sense, it's good for you, right? You're going to handle this stuff, and your app is going to be rock solid. So today I'm sharing lessons that I've learned through my day job. I've had the chance to write 2 apps so far. One was with the MVI pattern, the V1 for me. I was discovering a lot of things. And the second version, as part of a team, we did it in Kotlin and MVI, and we had a lot of good times. So also a lot of hard lessons learned, so I'm hoping that I can avoid you those hard lessons, right? The general idea for MVI is that you have your user and your view, which are kind of combined together. What do I mean by that? Well, if you think about a view at a very high abstraction level, that's what the user interacts with to interact with you. And when you put output on that view, that's when you feed back to the user, right? So a view is synonymous with users in this pattern. The view outputs UI view events. So whenever the user clicks or spins a recycler view or interacts with the screen, those are UI events that you want to turn into intents. The concept behind intents is that they are the logical work that you want to do on your model, right? So you take a view event, you turn that into something that makes sense for the model. So you take a click and you increment something afterwards. So the intent to increment a counter is passed on to the model in this example. The model would change, and then when the model changes, it will propagate these changes to the view who's subscribed to that model and listening actively. So this is not an invention of mine, or do I think is it an invention of Hannes Dorfman, but the best blog post you'll find on this stuff is linked here below on the slide. I recommend you check that out. All right, so we'll start with the model. The model, in our case, the first case we're gonna do is I'm gonna show you the pattern outside of Android. So just using Kotlin, the general idea, Kotlin and RxJava, general idea of the pattern, it's gonna be something we can run in a little test window, which I'm gonna do live after showing you the concepts. So we start off for our model with a data class. So in this case, the data class is gonna be called player. Player has a first name, a last name, and there's a score associated to the player. So right here we're using data class. Data class in Kotlin is an immutable data structure. So that has great benefits when you want to pass it around, right? So if you pass a player as is to a view, the view cannot mutate the player and cause all sorts of problems for everybody else that's sort of interested in that model, right? So the player holds our state. Now, the model itself is more than just a data state, right? So here we have the interface. The interface of the model is going to expose two things. So it's going to expose an output channel, which is an observable. So just for my own curiosity, how many people here are at least familiar with RxJava? Right? Quite a few hands. Okay, that's good. So in this case, we're going to be emitting players. So anytime a player changes, we're going to be emitting that player on the observable, and the view can subscribe to that and react accordingly. The other flip side of the model is the input side, so you have to be able to accept these intents, these logical intents to change the model. The view interface. So in our case, the view is going to be very simple for this example again. So we're going to have a render method where you can grab the whole player, and the view's job is going to be to display that somehow to the users. And on the flip side, on the output channel, we're going to have view events. So again, an observable, the observable of view events. Quite straightforward. So using Kotlin's sealed classes, what we can do is declare the type of events that our view will be producing. So in this specific case, we have intents to, view events. So view events in this case would be manipulation on a text view, for example, right? So if the first name changes, we're going to get a name change. If the last name changes, we're going to get that string as well. And if the user clicks on a button to increment the score, we get that click as well on the bus. Right, so those are the three types of view events that we will have to handle and turn into intents. So a big thing to remember is that view events are not intents, right? For intents, though, we're still going to be using sealed class here. Same kind of concept. The intent, as I said earlier, represent the action to be applied onto the model, and that's the big difference with view events. Right now, they almost look the same, but as our example is going to get more complex, you're going to see that there's going to be a divergence and that there's a reason for that split. So the other thing I have to explain here is the concept of a reducer. So if you see at the top of the class declaration right there, the reducer, again, show of hands, Kotlin, who's played around with it, familiar with it, totally, absolutely in love with it? Oh, okay, well, it's actually quite lovely. All right, so this is a function declaration, right? So the reducer takes as input a player and outputs a new player, a changed player. And that's important here. You might have been wondering, hey, he said that these player classes are immutable. How do we apply changes to it? So the concept is that a reducer takes something as input and outputs a new one, right? So you're not actually changing the original structure. You're just applying modifications to it and generating a new copy of it, which is also immutable. Right. So very important, again, I'm going to hammer this home. Intents have to be free of any view concerns, right? So that's the thing you have to keep an eye on. Okay. So intents being distinct from view events, how do we transform one to the other? So extension functions, for those of you kind of new to Kotlin, Kotlin allows you to take an object type and declare a new function for it and tack that on. So that gives you the very nice ability to tack on to observables, right? So here we say that for any observable of view events, we want to add this extension function called toIntent, and that's going to be transforming our observable of view events into an observable of intents. So that's one of the main tricks behind the MVI pattern. So underneath, we can see that there's a map function that's being called on the original observable of view events, and that we map one-to-one every single view event to an intent that is better representative of what we want to do to the model. All right. So basic view implementation, very basic view implementation. To publish an event, what we have here is that edit first and button click they call accept on the view events relay, right? So those are highlighted in yellow right here. So our view is very, very simple. We just basically we're going to have a script in our test run later that calls these functions to simulate a user interacting with the UI. On the flip side of that, the render call just takes a player and dumps it to the console. So that's our, fake view, fake UI. So here things get a bit more interesting. For the model, how do we implement a model? The main point I want you to take away from this slide, which we're going to be reusing a little bit later, is how the store is defined. But first, we're going to look at how intents are being captured. So we use a publish relay as an input point, which is not necessarily the best practice in Rx, but for this specific example, it does very well. And then our accept function just takes intents and stuffs them down that publish relay. The other reason why relays are acceptable in this kind of pattern is that they're kind of hidden from the world, right? So they can't be misused by outsiders to the model. And after that, let's look at store, right? So I mentioned how it was important, and the idea of store is that this is where our state is stored. And this is where we ultimately process all the incoming intents. So if I go over the chain, we take intents from the publish relay declared above. We map each intent to its reducer. So the reducer, again, is something that knows how to change a player from one state to another, although creating a new copy of it, right? And the magic pretty much happens with scan. So who here is actually familiar with the scan operator? It's kind of a Dart one, okay? That's kind of what I thought. So let's look at this for a second. All right, yes. Scan's actually not that hard to grasp, right? But that marble diagram, yeah, it's a bit intense. So if you look at the line of code below, the idea is that you give scan an initial state. If this was a number, you'd probably give it 0, right? But in this case, we have a player, so that we have the player first name, last name, and his score, which is 0. Now, the line underneath that is where we start doing stuff. So the idea is that we take the old value, the one that is currently being stored. So the thing about scan is that you kind of have to think of, which is kind of weird when you're used to RxJava in general, is that it is keeping state for you. There is a copy of the player that's held in your observable at the scan level. And that copy here is passed to your reducer function as the old copy, because by calling the reducer on that old copy, we're going to generate a new one, right, and store it in scan, ready to process again. So if you look at the marble diagram, in this case, the reducer would be, say, one of the colored balls up top, one of the colored marbles up top. And we're applying each of these operations and generating a new player that we keep in the scan operator. So this is giving us our storage. This is our storage unit, and it stores immutable values, right? So that's a big one, but that's an important one. If you take nothing else away from this talk, this is probably the biggest thing. Right, so map is how we extracted the reducer, and add. Then we have scan, which applies the reducer to our stored value. And after that, we have a replay operator. So the replay operator gives us something called a connected observable. So the idea behind the connected observable is that our store will have a copy of whatever is current available to any future subscriber that comes in. So again, marble diagram, but this one's a bit easier to understand. So the idea is that with replay, anybody that comes right after, say, the green marble has been emitted will be told, oh yeah, our current state is this one, right? So it allows us to sort of come in fresh. So if you imagine on Android, you have a fragment. It would come in, it wants to know what the state of the application is. It's basically gonna get the current state at the beginning as it subscribes to get future updates, right? All right, so 15 minutes, we're doing good on time. I think we're probably gonna be short on the explanations on Android side of things. Full disclosure, it's the first time I give this talk, so my timing might be a little bit off. But regardless, we're gonna go through this. The first part of the talk is really about exploring the pattern in general without the messiness of Android. And then we're gonna deep dive into the messiness of Android. So right now, okay, so I know this is complicated with this setup so far, but bear with me. We're gonna try to run the live demo. All right, so let's see. So you're probably seeing zilch right now. I'm going to mirror displays. I feel very daring right now. Is this readable? Yes, no. Yeah, yeah, okay. Yell at me if it's not. I can make the font bigger. All right, so we have our sample code right where? Oh, I'll have to look, bear with me. All this excitement, I forgot all my bookmarks and stuff. Okay, there we go. So let's hide this. Okay, so this is basically all the code from the samples I've been showing in the last few slides. So the idea now is I want to run the debugger through this test I built. So just to give a quick overview, we have a model store up top right here. We have our view implementation, and for those of you not familiar with RxJava, composite disposable allows you to store your subscriptions, store all your active Rx chains so that you can get rid of them later. All right, so let's start this and hope it works. Wait, that's not what I want to do. And I prepared for this, I swear. It should be fine. I'm a professional, I guess, sort of. All right. Cool. Yeah, I'm thinking the variable content is probably a bit tiny, but hey, whatever. Okay, so the real big important point is more seeing the console itself where all the outputs are gonna go. So when we start off the system, we get an output saying that Bob has 0 points right now. So how did this happen? Well, with the little story is that the subscription, like the store I showed you earlier, starts being active the moment it's constructed, right? So that initial state is actually right up and ready to go right at the beginning. And that debugging statement is outputted by the chain right here on the do on next line. So if you recognize this is our store unit, and unlike the slide, I have some debugging information to show us what's going on as we step through the code. All right, so if I step to the next point here, the first step in all of these things is to wire up the components. So right now, the first thing we do is we're gonna wire up the player with the view. So we have our model store. We get a player observable out of it, and we subscribe the view to it, okay? All right, so that's done. So right below, we see that the view render has received its first update. So if you remember earlier, I showed you the replay operator, and that's why we're getting this right now. We subscribed, and the replay operator gives us the current state of the system right off the bat. So the comments that are above is because I basically have the one-liner equivalent to these two things, but if we want to look at it in steps just to make it a bit more clear, to build the intent observable, the channel between the view and the intent, the first thing you do is that you take view events observable, and you call the toIntent transformer on it, so that gives you an observable of intent all of a sudden, right? And the next step, when you have an observable of intents, which is not yet active, it's not emitting, is to subscribe it to the model store. So this is nice, but we can do this in one line. So we like compact code, at least I do. I hope you do as well. And we go. So right now we just subscribe the view events, what the user would normally generate, to the model. So anything the user does from now on is gonna be captured by the model and is gonna update itself accordingly. So if, like simulating this right here, we have a button click. So when I have a button click happen, we can see below that a view event happened, button click, which was turned into an intent to increment the score, which is like a pure model concern. And then the player got a point. Now, once the player is updated, the view is also subscribed to the model, right? The model is gonna update on its own whether or not anybody's listening to it. It just keeps state, right? That's good. But the view being hooked up is gonna get an update, and it renders the final result, right? So to get a bit of a feel of how the chain goes, I'm gonna put a couple of breakpoints in there just to show you how it works, to get a bit of a more of an actual feel on actually what's happening. So one thing we can do, which is kind of interesting, I believe we have a couple of button clicks coming up. So if we put a breakpoint in the actual increment score reducer, we're gonna see the reducer being called from the scan function. So that's gonna be our example. I'm just gonna, and just to catch it, I'm gonna put this little breakpoint here so that if a few more button clicks happen, we're still gonna stop the demo. So I run this stuff, and right as rain, we get the breakpoint in the reducer being hit. Now, it's a bit tiny, so you're gonna have to trust me here, I think. But if you start looking at the chain of calls, which is kind of scary, to be honest, like any RxJava call stack. But if you look at that, you'll realize pretty quickly that the scan operator has been called, and it's the one calling the shots to get this reducer to work. And the reducer, as explained earlier, what it does is it takes the current player, named it in this case. Android Studio has a nice new feature now where it sort of tells you what it means. So if you're not familiar with Kotlin, the it represents the thing that you just received, right? And if you can type it out and explicitly give it a name. In this case, I did not do that. But Android Studio conveniently points out that this is a thing of a type player, right? So this is the old player. And the copy operator on data classes in Kotlin creates an immutable copy of the original after applying one change. In this case, we take the score and we increment it by its default value, which was assigned to 1 right here. So once that happens, we're gonna let the code run. And we see it hit and again. So if we look at the log, we see that the last increment was applied, and the intent right here is being blocked by our debugger. So it's gonna apply the next one. So we have another series of points. So I'm gonna take that breakpoint off. I'm gonna let the program run its course. It goes at the edit thing, and I'm gonna let it run the whole way through. And we can see in the output that all the commands were properly applied, and that the view render was called every time then the model changed, right? So this is the basic concept of MVI. You could run away right now and be like, oh yeah, I can probably apply this in my own Android programs at home. I'm sure you would be in good shape to do that, For the rest of the talk, for the time we do have, I'm gonna look at a few tricks. I think we're gonna be a bit short, but I'm gonna be looking at tricks that you can bring to your own Android program so that you don't struggle, as I have done when I was trying to apply this pattern to the life cycle and everything that goes with it. Now, before we go on, I'd like to mention that all I'm showing you today is available on my GitHub. I'm gonna show you the link at the end of the talk. So if we run short, and you're like, damn, I wish I saw all his examples so I could tear them apart and basically call them junk maybe later, or not, who knows. It's a constant work in progress, but that GitHub will be your reference. Like, you can take a look at it, and I'm pretty attentive if people write up issues or are curious, or have comments, or want to participate. So anyway, we'll get back to that later. Okay, so let's jump back to the projector and Keynote. Hopefully Keynote will behave. And we're in good shape. All right, cool. So, right, the actual Android app. So a few things. Who here is familiar with dependency injection? I'm guessing quite a few folks, right? That's kind of a pattern, well-known pattern nowadays. So my dependency injection engine of choice is Toothpick for these demos. It also is for work. So if you don't know Toothpick, it's a library written by folks at Groupon. I happen to know a few of them. They used to be a presenter at our local GDG in Montreal. They do really good work. The reason for Toothpick is twofold. Well, it's mostly because it's simpler than Dagger, to be absolutely honest. If you use it, you the little story is that I've worked on teams that have quite a resistance to DI, not because DI is a bad idea, but because Dagger. Because Dagger's too complicated, oh my God. Like, how can you, like, it's not worth it, the benefit's not there. And the thing is, it's like a chicken and the egg problem, right? Like, if you're scared of a tool because it's too complex, you're probably never gonna see the value because you're just rolling your own, right? So anyway, Toothpick is a nice solution out of that. So in this case, what we're doing here at the application level for our example, by the way, the example is a straight ripoff of the architecture design patterns from Google, right? So the to-do app that you'll find on the architecture samples from Google, that's exactly what we're working with today. All right, so Toothpick, what we do here is that we open an application scope, so that's where our model will live. That's basically our singleton that keeps our state, all right? And what we do on the next line in yellow here is that we register with the activity lifecycle callbacks. So what's nice with this, which I'm not gonna show on a slide, but you're just gonna have to take my word for it or go see the GitHub, it allows us to auto-inject activities and fragments without doing much more. So all we need to do at that point, once we have that, is have an @inject annotation on the right things in the right places, and everything magically works, which is basically the explanation of what's going on here when you look at these @inject annotations a bit later. All right, so the DI, what are we doing? So at the app level, we're declaring the 3 following bindings. So we have something called an intent mapper. So the names change a bit here, and there's good reasons for that. But the intent mapper is gonna be responsible for converting the view events, the concept of the view events I showed earlier, to more model-friendly intents, right? And there's a bit of work involved with that when your app's a bit more complex, so that's where that work will happen. The basic model, second thing, is where the state storage is gonna be taking place. There's gonna be a few key differences that I hope we're gonna have time to look at. And if not, I'm gonna jump to those because I think those are the more important concepts, but we'll see. And lastly, the view model. So that's a new layer I've added in this architecture in my own stuff lately. Originally, I didn't really feel a big need for that, but what happens is that at some point, if you have a pure logical model and you're trying to basically have the views subscribe straight into it, there's a lot of view concerns that you end up sort of coding in the view itself, which starts to look a lot like logic to basically massage the model's outputs into something more tolerable for users. So putting that in a view model layer allows you to reuse that stuff, also nicely put it away, tuck away in a corner, and not have a whole mess in your views. Right. And in this setup, and you have to understand that the view of model view intent in this specific example is really activities, fragments, and other view components, which are not strictly speaking views, right? There's a lot of controller-y type stuff happening there. But that's how we consider them as far as like the higher level thought pattern there, right? So when do we stop? We're at 10:02 or a bit later? 10:02, right? Okay. So I'm gonna skip over a few things, but very quickly, view events, same concept as we saw earlier. If you look at the little screenshot of the app, the idea being refresh task pull, when you pull to refresh or hit a refresh button, that's gonna represent that action. So when you're designing with MVI and you're on this layer, just think of anything that can be an input, or rather an output from the view that's gonna be an input into my model. Try to codify that really from the actual widgets on screen point of view, right? Then when you want to move from view events to intents, you're gonna have something very similar to what we had earlier with one new wrinkle, which is the big thing I wanna get through before we run out of time. And that's that you're no longer only dealing with reducers, but we're gonna be dealing with observable of reducers. Now you might be going like, why are we doing that, right? So the reason this is useful is that in some cases, you're gonna want to be changing the model asynchronously, right? So if your intent to change the model involves a web call somewhere, you're gonna do that asynchronously, and that's gonna come back. So an observable is really practical there. But not only that, there's another extra step. You might want to do this change in multiple steps. So the reducer observables allow us to do that. So what multiple steps could be involved, right? Well, this is an example. Fairly simple one, but you'll get the picture. So let's say we want to connect to our to-do data store in the cloud, right? We have a list of to-dos. We're going to grab them from the cloud. When we're not doing anything, so this is a little state machine, right? Who's familiar with state machines? I'm hoping to see a lot of hands raised. Okay, good. So our very, very simple state machine says that our model is in an idle state when nothing's happening. Fair enough. When we refresh, create, or update tasks, right, we're going to be in a process state, like with its own little flag that tells us exactly what it's doing. This process can either succeed, in which case we'll go back to idle, or it will fail, and then we'll get an error, right? So in the code, again, it's a sealed class, and we've just defined all the states of a little state machine right here. So where are we going to keep that state, you might be wondering? Well, let's first talk about how we make that state machine work. This one, again, is a bit panicky, I would understand. But the key points are not that bad, and we'll probably have to close on that, or at least close to. We have a few more minutes to go. So the idea, in general, is to create the observable of reducers that we just talked about, right? So the first step when you invoke this, so this is going to create the observable reduce, right? This returns that, the invoke method, function, sorry. Then the first step is going to be to right off the bat say, all right, first thing is we're refreshing now. That's a thing. We're starting a process, and we're in the process of refreshing. Nothing has happened yet, right? But you want to sort of publish that fact to the model before any kind of work starts, and that your current state is, I'm processing stuff. Then the next step at the REST service tasks get right there is to make the actual web call. If you're wondering, at the bottom, you can see that it's a retrofit call, right? So this is our asynchronous call. And you can see that we're subscribing on the I/O thread right here, the I/O scheduler. So this will be happening asynchronously in the background. And then we'll wait, right? So what happens effectively is that the model's going to basically tell the world, hey, I'm processing stuff right now. And then we're going to launch a job in the background, and eventually that job will come back. Just like the state diagram we just showed earlier, right? So if everything works nicely, what do? Our reducer that will change the state of our model is going to do two things. It's going to first officially say, OK, I'm back to idle. And at the same time, right, simultaneously, it will take the new tasks we have on hand and update those in the model. So our model has now a new list of tasks on hand and has published to the world, hey, I'm ready to, I'm done now. This is a new state that we're in. The idea of publishing the sync state is that if your UI wants to show the user something like a spinner, it can do that, right? You can do all sorts of interactions and sort of reflect the state of the app to your user, which is something that you usually will want to do at some point anyway. If there's an error, well, that's fairly simple. In this case, we're just going to log that error somewhere. We're also going to go back to idle afterwards, assuming in this case, since it's a REST call, that we can easily recuperate from this and we can just try again, right? So if you're missing network, what's going to effectively happen? Spinner's going to spin. It's going to fail out. It's going to show something to the console, and then the user can try again, which is fair enough error handling, right? OK. So we're going to be running over time now. So this is the step where I can cheat a little bit. So I'm gonna really pick my slides to what we should talk about at this stage. Well, what I do want to show you, yeah, the model here, we sum it up as an interface. Under the hood, the big difference with the Aereo sample I showed is here. So the only big difference is that we're taking the intents channel, and we're mapping it to reducers. So that means that we're going to take the observable of reducers and use the concat map operator at the bottom, right? and take these and exhaust them, basically. So what happens with concat map is that concat map makes sure that your observable of reducers is going to execute all the way through before anything else is sort of allowed to go through. This is kind of naive, but this is just to show like your basic implementation. So with everything else that happened and our little technical difficulties at the beginning, I'm afraid this is it. So thank you very much for your time. Pregnant pause. Now, they say speakers should never apologize, so I'm very sorry that we didn't go through the whole talk. The good news is I'm here all day, and I'm very happy to talk about this stuff. And I will show you the GitHub slide before we all go away right now. So if you're interested in this, please, I like to share and I like to talk about this stuff with people. So get on there, critique away, steal everything you can. I would be very happy if this is reusable for you. Ask me all the questions you want. I'll be happy to indulge. And yeah, thanks again, everybody. It was fun.